So we've been looking at adding and subtracting integer rules. In this lesson, we're going to look at how these rules relate to whether or not they are always true, sometimes true, or never true. So one thing before we get to these statements that we need to make clear is what's the difference, or what does sum and difference mean? Well, when we're talking about the word sum, we're talking about the word add. We are adding them together. And when we say difference, well, that's just another way of saying subtract. So now that we recognize this, let's look at our first statement together. The difference of two positive integers is blank negative. When dealing with statements like this, I like to first create a table. Number, this is where my sign's going to go. Second number equals, and then the value. If this statement is saying difference, are we adding or are we subtracting? Well, difference, if you remember back, difference is subtraction. So I'm going to place the subtraction in. This is the difference of two positive integers. So I know that this has to be a positive number, this has to be a positive number. And my result that I want it to be, I want the result to see whether or not it can be negative. So now that I have created this table, I can now place integers or values in that work. Well, what's a positive number? I could have 4, and I can have 2. For the second example, because I like to do 2 examples with these statements, I like to vice versa. I like to change those numbers around. So instead of having a bigger number first and a smaller number second, I'm going to have the smaller number first and the bigger number second, just to see whether or not there's any difference between the two. From here, now I can solve. 4 minus 2 gives me a positive 2. Did this give me the negative that I wanted? Nope, it didn't. It's not that I didn't solve it right, it just didn't give me a negative response. If I do 2 minus 4, well, for this one I have to do the additive inverse. Subtraction doesn't exist. So that's like saying 2 plus a negative 4, which results in a negative 2. Well, that one did give me the correct result. I did get a negative answer. So because I got one that worked and one that didn't, I know that this statement should have the word sometimes between it. The difference of two positive integers sometimes is negative. Let's try another example together. What about this statement? The sum of two positive integers are blank positive. Well, I'm going to still create that table of values. Number, sign, number, equal, and then the solution. It says the word sum. Sum in this case means addition of two positive integers, so I know this is a positive, this has to be a positive, and I want to know if the results are positive. My table's ready, so now I can come up with values that work. And just like before, when I come up with examples, I'm going to change those numbers around a little bit. So a positive number, well, I like the number 4, so let's stay with that one. I got 4 plus 2. Are those both positive? Yep. 4 plus 2 is 6. Positive plus a positive give me a positive, so I can put a check mark by that. That worked. I had a big number first and a small number second. So let's try it vice versa. 2 and 4. Now I have a small number first and a bigger number second. 2 plus 4 gives me a positive 6. So in this case, did the sum of two positive integers always result in a positive response, sometimes, or never? Well, both examples were positive. So I'm confident enough to say that if I'm adding two positive integers, they are always going to be positive. Let's look at a third example. The difference of a positive and a negative integer is blank positive. So I'm going to create my table again. Number, sign, number, what it equals, and then its solution. Well, the operation that they want me to do is difference. So difference in this case means subtraction. It says the difference of a positive and a negative integer. Now, it's important that I write these down with what was said first. They said positive first, so my positive number has to come first. They said negative second, so my negative answer has to come second. And I want to see whether or not this results in a positive response. Okay. Let's come up with some numbers. I have 4. You know what next number I'm probably going to do. I can't do 2, but I can say negative 2. And vice versa, I'm going to change these numbers around. I had one big and one small at the beginning, so I'm going to change it around now. I can't write negative 2 for this second space right here, but I can write it as 2. That's perfectly fine. 2's positive, negative 2's not though. I can't write 4 in this second number, but I can write it as negative 4 because my second number has to be a negative number. Now in difference and subtraction, we have to remember that we have to keep, change, change. So if I resolve these, I keep the first number. I'm just going to write that right over here. I change the sign. I change the second number. Negative 2, the opposite of negative 2 is 2. And I find that I get a 6. 4 plus 2 equals 6. So that worked. A positive minus a negative did give me a positive response. Let's see if it works for the second example. Get rid of that subtraction. I keep the first. I change the sign. I change the second number. The opposite of negative 4 is still 4. 2 plus 4, that equals 6. So this also worked. So the difference of a positive and a negative integer, well, both times resulted in a positive, so I can say always. It is always going to be positive. Let's do one more example together. Creating a table of values. I want to see whether or not the sum of a positive and a negative integer will always, sometimes, or never result in a negative response. So I'm going to create my table of values. Number, sign, number, equal, solution. Sum represented addition. So I'm going to write addition in here. Order matters. It gave me positive first, so the first number needs to be a positive. It gave me negative second, so the second number needs to be a negative. It gave me negative last, so the solution needs to be negative. From here I can come up with my values. My table's ready to go. Positive number, well, let's change it up. 5 plus a negative number. Let's try a negative 1. 5 plus a negative 1 will give me a positive 4. So did that result in a negative response? Nope, it didn't. So that one doesn't work. But we always want to do 2 examples to see whether or not it's sometimes. If we only do 1 example, then we're not going to always know. I did one big number first and a smaller number second, so I'm going to change it up. I'm going to do the smaller number first, smaller absolute value number first, bigger absolute value second. I can't write -1, but I can write it as 1 because my number has to be positive from up here. It says it has to be positive. I can't write 5 in the second column, but I can write it as a -5 because my second number has to be a negative based off of this. I can then add these two together. 1 plus a -5 is going to result in a -4. Now this one worked. When I added 1 plus a -5, I did get a negative response. So in this case, the sum of a positive and a negative integer sometimes will result in a negative response. So key things that you want to remember when you're dealing with these always, sometimes, never statements. 1, create a table. This lovely table right here that you can kind of see me bolding in will help provide examples for you so that you can see whether or not it's going to result always, sometimes, or never. 2, pay close attention to what came first when you're labeling your table. In this case, for this example, they wanted a positive number first. So your numbers that went in the first column had to be positive. They wanted a negative number second. So your negative numbers had to be in that second column. Lastly, when you put these numbers in, make sure that you're trying to do one large absolute value first, and a smaller absolute value second, and then change them around. Do the smaller absolute value first, and the larger absolute value second. This will unlock whether or not the statement is always, sometimes, or never.